Okay, so my voice is audible to you all?
Yes, ma'am.
Okay. So today we will learn about distress algorithm. Actually, we have been learning about minimum spanning tree, and we have learned that minimum spanning tree gives us the shortest path between the nodes or the vertices. So if it also gives us the shortest path and distress algorithm also gives us the shortest path, then what is the difference between the two? Fine, there is one question. What happens in the minimum spanning tree, that is in the Prim's and Kruskal's concept which we have learned, given a graph to you. So suppose if these were the nodes given to you and this was the graph, suppose, which was given to you, you find a spanning tree that will connect all the vertices and it will give you a minimum weight of the spanning tree, right? A minimum cost. But in doing so, suppose this edge is excluded, this edge is excluded. So it is does not guarantee that it will, suppose if this edge is excluded, so we cannot go from here to here, right? If this edge is excluded, we cannot directly go from here to here. So it may happen that we have to go here via this. So this is the concept. So the thing is, in finding out the minimum spanning tree, what happens is few of the edges, they are eliminated. We have a tendency or we have a aim to connect all the vertices so that all the nodes are connected, but in a way it does not guarantee that all the edges which will be included. While on the other hand, given a graph to you and suppose a source node is given to you, this distress algorithm, it will find the shortest path between a node and every other node. That means if this was your earlier graph, which was given to you, suppose this was your graph, and if I say this is my source vertex, then it will find the minimum path from this vertex to this vertex, minimum path from here to here, minimum path how to reach from here to here, minimum path how to reach from here to here. So all the nodes how we can reach with minimum weight, it will give. So given any source, it will tell you how we choose the shortest path in order to reach every other node. This is very important. Every other node, it will give you a way to reach, including the shortest path. And but in MST, what happened is it will give you an overall cost, a overall shortest path selection. It may happen in that from here, from this source, I cannot reach this. It may happen, but here it won't happen. This is one difference between the minimum spanning trees concept and this distress algorithm concept, because both of them helps you to find the shortest path only, but how it helps you, a little improvisation is there. And also this algorithm we can also use in order to find the cost of the shortest path from node to from source node to a destination node. We can have the shortest path. So what happens in what happens in distress algorithm is that it is an optimal algorithm, or I can say this algorithm, it is used to find the length of the optimal path between two nodes in a graph. So it can specify that start from node A or B or C, just like the other algorithms. You can start from any vertex, marking it as a source vertex, but it will give you, the output will be from that source vertex, how to reach every other vertex with minimum weight. Whereas in prims or Kruskals, they give you a overall weight, overall low cost weight of the graph, or overall path with the shortest path of the graph. It doesn't consider from source vertex to every other vertex, it doesn't consider. It will give you an overall minimum weight or minimum cost of the graph. Is the difference between the two clear to you people? So the point where these prims or the MSTs or this discuss differ is, what happened in Prim's algorithm is a minimum cost edge is stored, and only we considered the minimum cost edge. Whatever vertex was fulfilling in that edge, we would consider it. But in Dichters algorithm, the total cost from a source node to a current node, all these things will be taken into account. Now we will just see an example and we will see how we are actually doing it. So first I will just draw one graph. Okay. So let us consider this is our graph which is given to you. What will happen in, I will just, okay. So let us think this is our, one will be explode vertices and another section will be unexplored vertices. Now how the concept works, I will just discuss. Okay, so just like the concept of other algorithms which we were studying, first we will delete any loops. So the first condition is delete all the loops if any. There are no loops, so it's not a problem. Then I will delete parallel edges. I will delete parallel edges except the one with minimum weight. Fine. So suppose from C to A, another edge was there with weight 1. So I would have kept 1 and deleted 4 finally. Fine. So we will delete all the parallel edges, but among the parallel edges, if any, the one with the minimum weight, I will choose and keep. and we will start from any vertex, and that start vertex I will refer or mark as my source vertex. Fine. So suppose here I am starting from A. So A is my source vertex. You can start from any vertex. The starting vertex which I will be starting for, this vertex will be labeled or will be permanently labeled at 0. Fine. And the other vertices will be temporarily labeled at infinity. So these are basically the 4 rules which we need to want. We will delete all the loops if there are any. We will delete all the parallel edges in my graph except the one with the minimum edge. I will keep that. I will mark one vertex as my starting vertex. Anyone I can choose. If not written which one to choose, I will mark that vertex as my source vertex, and I will permanently label that vertex as 0. And all the other vertices I will temporarily in the first step label at infinity. And step by step, when I will find out which is the minimum path from my source to another vertex, like on and so on, I will calculate and I will update my weight of my vertices. Now, how I will calculate and how I will update, this we will be learning. And this concept or this procedure will go on until I have finished visiting all my vertices. Fine. So at the first stage, what will happen? My A is the start vertex here. So it is labeled at 0. And all other vertices B, C, D, E, F, and G, all other vertices are labeled at infinity. Is this step clear to you? Yes or no? Is this step
मैम
clear?
एक बार और बता दीजिए.
हाँ?
एक बार और मैम.
स्टार्ट वर्टेक्स जहां से शुरू कर रहे हैं उसको हम 0 वेट दिए हैं, और बाकी सारे वर्टेक्स जो अभी कैलकुलेट नहीं किए हैं टेम्पोरली उसको इंफिनिटी सिंबल देके लेबल किए हैं. बस इतना सा ही है. फाइन. नाउ I will always choose the minimum from my unexplored vertices list. So from this unexplored vertices list, you tell me which is the minimum vertex with the minimum weight?
मैम डी. ए से डी.
A से D ही नहीं, बस vertex by vertex I will proceed. So जितने भी vertices है, A का weight 0 है और सारा vertices का weight infinity है. So obviously 0 is lesser than infinity. So I will choose the vertex with the minimum weight from my unexplored vertices list, and I will come and keep it in my explored vertices list. Fine. Now, once I have kept it in my explored vertices list, I will see what are the vertices that can be reached from A. I can see one outgoing direction from A to B and one outgoing direction from A to B, right? C to A is inward. So from A, I cannot reach C. So from A only I can reach B and I can reach D. Yes or no?
Yes मैम.
Yes. So the rule is, now the vertices which I cannot reach, I will keep it as it is in the previous step. So C, E, F, G, I will just copy it with the weight infinity. I will just copy it from the previous step. The only 2 edges which I will update is B and D. Now what will be the weight of these edges? The weight will be whatever weight is here, last एक्सप्लोर्ड वर्टिसेस में लिस्ट में जो है उसका जो वेट है प्लस उस ए वर्टेक्स से इस वर्टेक्स का जाने का जो वेट है वो ऐड होगा. सो बी के लिए कितना होगा? 0 + 2, isn't it? और डी
Yes,
के
ma'am.
लिए कितना होगा?
1.
1. 0 + 1. सो हम लोग ए से बी गए, ए से डी गए, 0 + 2 0 + 1। सो हम बी के यहाँ पे लिखेंगे 2 साइड में ए, एंड डी के यहाँ लिखेंगे 1 साइड में ए। इसका मतलब we can reach B via A with the minimum weight 2. We can reach D via A with the minimum weight 1. Is this clear to you?
Yes, ma'am.
Yes, ma'am.
अभी इस लिस्ट में सबसे मिनिमम कौन है?
D.
तो हम उसको कॉपी करेंगे, एक्सप्लोड में लाएंगे। सो अभी एक्सप्लोड में ला दिए, फाइन। अभी देखो डी से कहां कहां जा सकते हैं हम? डी से सी जा सकते हैं, एफ जा सकते हैं, जी जा सकते हैं, ई जा सकते हैं, राइट। सो हम कौन सा वर्टेक्स डी से जा नहीं सकते?
B और A.
D.
ए तो आएगा ही नहीं क्योंकि ए तो एक्सप्लोड में चला गया है। यहां से
मैम B.
बी, डी से हम बी नहीं जा सकते, तो बी मेरा जो यहाँ पे है वो हूबहू कॉपी हो जाएगा। जो नहीं जा सकते दैट विल बी कॉपीड जस्ट लाइक द प्रीवियस डे। और सी एफ जी ई ये हम जा सकते हैं। सो ये हो सकता है आपका अपडेट हो, ना भी हो सकता है, क्योंकि अगर मिनिमम नहीं होगा तो अपडेट क्यों करेंगे। अच्छा, तो अभी अगर हम डी से सी जाते हैं तो मेरा सी का वेट क्या होगा? लास्ट कौन सा वाला एक्सप्लोड है मेरा, उसका वेट क्या है?
1
प्लस
2
2
plus 2 3 मैम।
3। और कहां से जा रहे हैं हम?
D से।
D.
फिर आप लोग यही कॉन्सेप्ट यूज करके ई एफ जी का बताओ कितना होगा?
मैम E का भी 3D,
राइट। एफ का?
F का 9D
राइट।
9D.
जी का?
और G का 5D 5D।
5D.
नाउ ये क्वेश्चन आता है कि हमने सारा अपडेट किए, क्यों किए? क्योंकि जस्ट प्रीवियस वाला स्टेप में मेरा सारा इंफिनिटी था। सी भी इंफिनिटी, एफ भी इंफिनिटी, जी भी इंफिनिटी, ई भी इंफिनिटी। So obviously the value I have put 3 is lesser than infinity, 9 is lesser than infinity, 5 is lesser than infinity. So I have updated. 3 was lesser than infinity, 5 was lesser than infinity, 9 was lesser than infinity. So I updated. But if in calculating I get any value which is not lesser than the previous row value, I will not take the updated one. I will just copy the previous one. ओके अगर अभी ये रो देखते हैं तो मिनिमम मेरा कौन सा एक्सप्लोड वर्टिसेस लिस्ट में इस रो से यहाँ आ जाएगा?
B।
बी। फाइन। अभी देखते हैं बी से हम लोग कहाँ जा सकते हैं। बी से हम लोग डी जा सकते हैं, जो मेरा जरूरत है ही नहीं। डी तो मेरा ऑलरेडी मिनिमम वैल्यू होके आ गया है। बी से हम लोग ई जा सकते हैं, राइट, और कहीं नहीं जा सकते। तो सी एफ एंड जी मेरा एज इट इज बैठ जाएगा जो मेरे पास है। अभी देखते हैं ई में मेरा अगर हम लास्ट अपडेट थ्रू बी लेते हैं तो ई का मेरा वैल्यू क्या होगा?
12।
12B.
और लास्ट रो में ई का वैल्यू क्या है?
3।
तो हम लोग क्या 12 को अपडेट करेंगे?
नो मैम।
12 मेरा 3 से ग्रेटर देन है ही नहीं, तो हम इसको ही रख देंगे, अपडेट नहीं करेंगे। अपडेट का जगह अपडेट करेंगे, अगर नहीं है नहीं करेंगे। अच्छा, तो अभी मेरा नेक्स्ट स्टेप के लिए इस रो से मेरा 2 मिनिमम हो गया है, सी या ई, आप किसी भी एक चूज कर सकते हो। आपका दो अगर सेम जगह पे आ जाते हैं, आप यू कैन चूज एनी वन। सपोज आई एम चूजिंग सी। फाइन। अभी मेरा सी यहाँ पे है, सी से मेरा ए जा सकते हैं जो हम नहीं लेंगे। सी से मेरा एफ जा सकते हैं, वो लेंगे कि नहीं लेंगे वो बाद में देखेंगे। तो मेरा नहीं जा सकते हैं ई और जी, तो हम पहले हूबहू उसको लास्ट स्टेप से कॉपी कर देते, राइट। अभी सी से मेरा अगर एफ जाते हैं तो मेरा एफ का वैल्यू क्या होगा फाइनली?
8C.
8D.
8
C.
Yes, ma'am.
8 क्या है?
8C.
8C,
8C.
राइट। वाया सी था, 3 ऐड होगा 5 के साथ, तो 8C। तो ये वाला स्टेप हम लेंगे बिकॉज 8 इज लेसर देन 9। आपका इसमें था 9 और यहाँ पे है 8, तो हम 8 को लेंगे, इसलिए हम 8 को अपडेट कर दिए। अभी फिर से हम अनएक्सप्लोर्ड वर्टिसेस से एक एक्सप्लोर्ड में लेके जाएंगे, तो मिनिमम वेट मेरा ई है, तो ई को ही लेके जाएंगे। तो पहले लेके जाते हैं, फाइन। अभी ई से मेरा कहाँ जाएगा? ई से सिर्फ जी की ओर जाएगा, तो एफ तो मेरा एज इट इज कॉपी हो जाएगा। अब जी क्या मेरा अपडेट होगा, यस और नो?
No, ma'am.
No, ma'am.
No, ma'am.
हो जाएगा अगर ये लेते हैं 6 + 3 9, पर यहाँ में मेरा है 5, सो 9 is not lesser than 5, so I won't be updating it. I will keep as it is. Now यहाँ से मेरा G आ जाएगा एक्सप्लोर्ड वर्टिसेस में नेक्स्ट स्टेप के लिए। राइट, अभी जी तो देखते हैं, जी से हम एफ जा सकते हैं, राइट। एफ क्या अपडेट होगा, यस और नो?
Yes, ma'am.
Yes, ma'am.
और वैल्यू क्या होगा?
6G.
6G, ठीक है। ये मेरा 8 था, 8 is not lesser than 6, so yes I will take the new value 6G। तो अभी इसको भी हम यहाँ पे ला देंगे, A0 D1A सॉरी B2A C3D E3D G5D F6G, ठीक है। हम लोग यहाँ से स्टार्ट किए, सारा एक्सप्लोर खत्म, हम लोग यहाँ पे स्टॉप किए। अभी इसका मीनिंग क्या हुआ, अभी वो लिखते हैं। ये जो हर एक चीज यहाँ पे हुआ, हम जो बोले फ्रॉम वन सोर्स वर्टेक्स टू एवरी अदर वर्टेक्स का रीच करने का सबसे मिनिमम पाथ क्या है, ये जो निकालेंगे इसका मीनिंग क्या है। फाइन, सो my source vertex was A, right, and all the other vertices was B, C, D, E, F and G, right? So what is the minimum path to reach B, C? Via A. So A to B and the weight is 2. What is the minimum path to reach C? I will look for that vertex. So from A to C via D. So the concept is A, D, C with weight 3. Now you tell me what is the minimum path to reach D via?
A.
A1.
What is the minimum path to reach E?
D. D.
तो लिखेंगे कैसे? A, D
AD.
and the weight is 3. D reach करने का मिनिमम पाथ है A, B
D.
and the weight is 5. Sorry. And the weight is 5. F is A, B, F and the weight is 3. So you can see that from this source vertex, I can reach all the vertices, and this is the minimum weight to reach that. This is the entire concept of digital scanning. Is this entire concept clear to you?
Yes, ma'am.
Okay. So in several books, different ways are there. In one book, if you follow the mathematics book, you may see that matrix is followed, where they circle and they reach from lower to bottom. A matrix pattern is followed. But if you look some standard books, you will see this pattern is followed. So it doesn't matter that in which form they are representing, but this is the concept. That is, the source vertex is labeled as 0 and all the vertex are temporarily labeled at infinity. And one by one, step by step, we select the minimum vertex from each step. And how do we get the minimum vertex? I add the permanently labeled vertex just in the explode vertices list with the weight of that edge. I add the two. And if I see that just before the row, the weight that was previous of that vertex is minimum, then this thing, the updated thing is minimum, then I will write the updated value. And if I see that the updated value is not minimum, I will just simply copy the previous value. Now this I have showed with directed weighted graph. It can be showed with undirected weighted graph also. Then the thing is, the few edges which I have not considered for A, like this edge was an invert, for that instance, I will have to consider this edge. But this is the difference. It can work for both directed and undirected weighted graphs, not an issue. Okay. So this was the entire concept of about Dirichlet's algorithm. So anyone has any doubt in understanding this algorithm?
No, ma'am.
Okay. So I will just share the attendance. So the same thing, the people from this college, they can just mark their attendance in the LMS, and the other people write your name and your department in the chat box. Yes, mark your attendance here, and after marking your attendance, you may leave the class, and the other people, after writing your attendance in the chat box, you may leave the class. And if you have any query, you may ask.